in this class, we're going to look at Cramer's rule. What is it all about? This is named after a Swiss mathematician by the name Gabriel Cramer. It is a rule you can use to solve simultaneous equations. If you are given something like this to solve, Cramer in 18th century proposed that all you have to do is to take the coefficient of this s, y, and z, arrange them in a matrix 2, 6, 1. This is 5 minus 4, 9. While this is minus 3, 3, 7. Then you put s, y, z here equal to 1, 2, and 5. Okay? It said you should arrange them like this. That is Cramer. So arrange them in this format. Once you finish arranging them like this, he said the next thing you need to do is to find the determinant of this. So the first thing, to find the determinant of this. Let's assume that the determinant of this is D. Okay? He said once you have the determinant, to get X, he said this first part, which represent X, as you can see in this place, remove its value and put this value there. That is 1, 2, 5. Let me remove this particular one. Okay? Once I replace this with this, all this other one will still remain. 5 minus 4, 9 minus 3, 3, 7. So, divide by D. So what I will say, once you remove this and put these values there, also find the determinant of this. Divide by the determinant of this raw one, which is D. Remember, this, we said its determinant is D. We remove this and put this here to have this. Calculate the determinant, divide by the determinant of these original values. This is for X. Okay, let me do this. For Y, it said, because Y is at the center, retain these values for X. Retain this value for X. For Y, replace them with this value. Then retain this one for Z. Once you do this now, find the determinant like this, you're going to have Y. It said for Z, the same process. Retain coefficient of S and Y, but that of Z, put these ones. That is 1, 2, and 5. Divide by the original determinant. This is how to get the values. Okay? With this now, let's look at this example. Solve the following simultaneous equation by using Cramer's rule. Okay? So the first thing we need to do is to come down to put this 3, 6, minus 2, minus 4, 3. I'm just going straight to solve it. I'm not going to arrange them like this again. This one, I'm dropping this, okay? 1, 8, minus 5, 3. This is the first thing I need to do. First of all, I find the determinant of everything. You agree with me? This is 3, 9 plus 5 plus 4, because of this minus, 18 minus 10 plus 8, 6 plus 6. This is 3. This and this will give us 14. This will give us 8. This will give us 12. That is 42, 32, 96. Okay? That is what? 170. This is going to be the denominator for all of them. Okay? Now, to get for S1, all these coefficients, we're going to replace them with this. That is 26, 1, 11. Then we retain the other ones. Once you get the determinant, divide by 170. Okay? The other one, that is this for S1. For S2, we retain this, then we replace the middle one with this value. That is 26, 1, 11, 8 minus 5, 3. Divide by 170. To get for S3, we retain everything. That is 3, 6 minus 2 minus 4, 3, 1. This last part we put 26, 1, 11. All over 170. Okay? These are to get their values. So all we have to do now is to follow the normal mathematical jargons and solve the determinant that divides. So I'm not going to do that. Now you have the idea on how to use Cramer's rule, okay? If you want to practice, look at this question. You can use Cramer's rule to do this, okay? If you want to practice, you can use Cramer's rule for that. Solve the following using Cramer's rule. These ones. And at the end of the day, if these are your answers, you know that what? You are in the right path, okay?